Our first speaker today is Cassandra Mercury. So she's the Space Quantum Technology Lead at Craft Prospect, an aerospace company based in Glasgow, where she is leading the development of the quantum key distribution payload for the upcoming Responsive Operation for Key Services mission. Cassandra has also previously worked on other exciting space projects with NASA's Jet Propulsion Laboratory, including Mars rovers, supersonic decelerating technologies, and the hyperloop one. Today, Cassandra will be talking about managing projects, managing people, and yourself. So yes, and if you have any questions for Cassandra throughout this talk, please put them in the Q&A chat. And if you see any questions that you think are particularly good and want answered, upvote them. So without further ado, I can hand over to Cassandra. Thank you very much for putting on this talk for us. And yes, the floor is yours, or the Zoom is.
Thank you very much. Yeah, so I'm Cassandra Mercury. Like Dave said, I'm at Craft Prospect and currently the lead for the quantum key distribution payload that we're looking to launch at the end of next year. So that's going to be an in-orbit demonstration of the full quantum key distribution system, transmitter in space, receiver on the ground. We are fully, we are an industry startup. So we're still a small company. I believe we have about 17 people at the moment. And we partner with a couple of the universities. So universities of Bristol and Strathclyde being the main partners for the QKD portions. So I'm going to go into a bit about some of the differences in the approaches between academia and industry and how that changes how you manage a project when you have combination of these two types of partners. So one of the things that we have here, I'm just going to share my screen. Oh, host disabled participant screen sharing. Dave, can we allow me to, oh, there we go. Let's see. Sure, okay. So one of the things is that a lot of the funding so far has come from certain UK government organizations. And what they really want to focus on is the interplay between academia and industry. And it allows them to really promote the idea that we should be getting a return on investment on the UK's money. And so you have to have an industry-led partner, the industry partner is the lead on the project, and then academia's, as partners within that consortium. So consortiums are a big thing of what the UK has been trying to do here. So if we start, let's see, there we go. So the first thing to understand is the differences in motivation between academia and industry. And this is very important in determining what it is you want to deliver, because academia generally, the motivation is in novel results. It's in furthering the knowledge of all humanity, and really the industry's motivation is to get something they can sell. And so that's an important distinction between the two. And when you're trying to manage both industry and academia partners, knowing what those expectations are on both of those partners is the important part of bringing together a cohesive project. Because for the most part, it's a success if, for academia, if we gain more knowledge, if we push the state of the art, if you get novel results. But that means nothing to industry if you don't get something that has commercial viability at the end. And so making sure that you have both of those needs acknowledged is important at the start. And that goes into success. What does success look like for your industry partners, and what does it look like for your academia partners? And for academia, you'll have requirements. It's not like it's completely free floating here. But for industry, all requirements have to be validatable. So it's not just you've got a novel result, there's a result that you wanted and that you're able to see that you made it. So you have to fulfill that requirement. And the big part about this is the requirements definition at the start of a project is probably the most important part of a project. So it's a lot of front-loaded effort, but getting everybody on the same page of what it is you want to deliver is really the key to getting success for the end of that project. A lot of times, it's easier to have assumptions about what success looks like because it's always generally obvious to you what you want to do, but it's the differences in partners, in academia, in industry, in some of those quasi-governmental organizations, which kind of span the gap between the two. Success all generally looks very different in what they're trying to do. And so translating cool new improvements and interesting new science into what it is can we sell, and distilling that into requirements so everybody knows what success looks like is probably the most important thing you can do to guarantee that your project is going to be a success for all the partners involved. So that's one of the key items is you never want to have one of the partners being the one that gains everything. And so the other partners, being the one that sacrifices. You need to make sure that success is success for everybody. And I think this one really shows one of the key differences, and understanding this chart is very important to figuring out how to manage the interplay between academia and industry. This is an agile project management start. And what it describes is a project and the items that go into a project. You have your timeline, you have a cost, that your budget that you can spend. There's certain benefits of the product that you're trying to build. There's the risks involved. There's the quality, so this is the validation, and then there's the total scope of, how far are you going to be pushing this novel new product? And what this shows is, and it's very much an industry-led, agile is an industry-led project management style, is what's important for the project management. And it's called, there's fix and flex. Fix means these things should not change. So if halfway through the project something has changed, the fixed items should not. If they have to, it's called an exception, and it's a large process to go and redefine those. But throughout the project, you're never going to have a perfect plan at the start. No matter how much time you spend on those requirements, no matter how much time you spend on anything, things will never go exactly to plan. And that's fine. That is how projects go. And in the agile, that's actually welcomed, because change means you learn something and you adapted to it. So you're supposed to go with change. But what that means is that your requirements might have to change, and that's where flex comes in. So perhaps you're running out of time, you won't be able to get through something, you might cut back on that scope, or on all the benefits of this new product. How is it going to be different than the other things? You might cut back on that. And so the key part here is that the time and the cost, those are the two things that are fixed. You don't flex on those, because those are the things important to industry. You can't overspend your budget. Again, industry generally budgets pretty strictly on what they're able to do. There's just a certain amount of money that they have. And in timeline, you have to be able to get a product out within a certain amount of time, or else your company might have issues being a going concern. If you're always missing your deadlines, that means you're not selling the things you're creating, which means you're causing cash flow issues, which can very much hurt the business. So I think this chart really shows it, because what are the things that you can change if you're halfway through the project? Murphy's Law has struck you 1,000 times and you're way behind. Well, the things you should be starting with is the scope and the benefits and what comes out of it. And it's not the time and cost. And that's a very key difference between industry and academia, because often in academia, you don't get as far along, but you continue on with the items you were that you were trying to solve. With industry, it's what possibly can we cut and still have a sellable product at the end. And so getting that key difference and understanding the motivation between industry and academia there is key for both partners, is to explain why decisions get made. Because oftentimes, you know that there's there's improvements to be made, but often you have to not make them in industry because time is running out and you can't flex on that. You need to get something delivered. For example, Craft Prospect is currently working with the University of Bristol and Strathclyde on delivering a quantum source module. And we have a very strict timeline because it's to be flown on the KeySat mission that Canada's doing. So that's Canada's quantum key distribution mission. And we have certain decision gates that we have to meet. So it has to get over to Canada. Canada has to do their evaluation, and then they give us a go, no go of whether we can fly with them or not. And if we don't meet that deadline, we automatically get a no-go. And obviously that would be devastating for us and, for all the work we've been putting in. All of the partners want to see this flown. But what does that mean if you're running behind on the build process? It means that some of the benefits of the product that you are making, that they have to be cut. And you have to be quite ruthless, and you have to be really, ruthless is probably the word for it, because that's what it feels like when you stop design changes, because you might still see paths forward that you really want to explore, that if we just spend some time, if you have another month to spend, you can solve this problem. But if you spend that month, you miss your decision gate. And so the time cannot be flexed. The time is fixed. And so you have to be ruthless and cut things out. And I think that's the hardest thing to do, especially when you're working with your academic partners who know that they have the solution for it if they can just spend a bit of time on it. And that's the part where you have to be the most ruthless. And then there's differences in timeline in two different ways. So one is you generally have a project life cycle. If you're getting a grant from the government, it has a set timeline. Here's the project end date. And for the most part, they don't extend that. And they're not going to give you extra money if you do request an extension and if they're willing to grant it. So for academia, project end date, it ends whatever you're able to get at the end. That's your product. You do your report. For industry, no matter how novel of a thing you did during your project life cycle, if you do not have a pathway to having commercial viability, if you don't have your commercialization plan realized by that time and you have that money flowing in, it was a failure. And so that's a key difference in that you have to have something that has sellability. And it is something that the UK government has been realizing with like Innovate UK, like their grants. They always have a part called the commercialization plan now, and or sometimes exploitation plan. And it's how are you going to use the money they gave you to build something and then get return on investment for the UK's money to sell. And so that is why they're requiring an industry lead, because that's also industry's requirement on something, is that they have to have a sellability plan at the end. And so keeping those, where the dollar bill is coming in from at the end is the key part. So the timeline, it's not just what you can get done in the, or what novel things you can get done in the time that you have. It's what can you sell within there. And that also goes into, the talking between the industry and the academic partners. One of the most important things at the start is, as part of that commercialization plan, is the contracts to basically be able to develop that IP and to commercialize it. And so the industry obviously has more experience with that portion, so they take care of that, and it allows the academia knowledge to spin out and become usable products. And then there's one other thing in the timeline, which is kind of the opposite of what I just spoke about. And it's about basically decision making. And it's something to be aware of whenever you're doing project planning. So when you're in a university, there's very set processes, there's bureaucracy portions. Generally, there's an idea of how you have to be the steward of the money. Bids go out for tender, and they come back, and things can slow down inexplicably. One of the projects that worked on with University of Bristol, we were delayed on our telescope development simply because of a problem with the door not being large enough. And I believe that was a 6-month item to fix at the university, which baffled us. But the contractor had pulled out, so the tender process had to start all over again. And so that's something for industry has to be aware of, is that when you're leading a project, there's certain things that the university is able to push forward and certain things that they won't be able to. So no matter how much it also frustrated our university partners, one of the big things about project management is knowing where the limits are for all your partners. And that was a limit. There was just a waiting process on a door, which led to large project delays, which is not a thing that generally happens in industry, because there's not going to be a 6-month delay of something where they can just say, we know we need it, we're just going to go and spend the money, and we're going to just make that quick decision, and that decision can be made in an hour instead of months. And so then another key difference, and one thing to be aware of as you have projects between both industry and academia, is funding and where it comes from and how it's given. So like most of the funding, if you're getting grants for universities, they're 100% grants. So basically the university doesn't have to put its own money into the project. But for those same projects, any industry partners do. So it's what's called matched funds. So that could be anywhere between 20 to 50%. And so if you say, hey, this project is going to cost the industry partners, it's a £100,000 project. And if there's 20% matched funds, well, then the industry partner is expected to put in £20,000. So it's a much different calculus of what projects to go for and what has actual viability than academia ones, which is you'd get the 100%. And so that's a large key difference there is, who pays for what, where's the money coming from? Because where does the matched funds from the industry come from? Well, it has to come from other things they've sold. So other commercially viable products they have that are then funding this R&D effort to get more. And so there's a very keen, basically calculus on, is it worth it? And so that return on investment is always at the top of the mind for industry, where it's not generally for academia. And understanding those key differences for what you can go after when you start partnering in a greater sense, instead of just on a particular project with industry and academia, is important to making sure that that relationship stays strong, and what you can do and what you don't have the money for. And so that's a big difference there in how the terms of how the money comes. And then it's publishing is actually something that academia and industry really has similarities on. We both want to publish. Now, academia has slightly different reasons for wanting to publish, as the little cartoon shows. Publish or perish, you have to get that out there. And the reasons for industry is something, I really don't have a better term for it than thought leadership. And I don't really like that one. But publishing what you've been doing, the novel things, the novel products, how it's advancing things is important for industry as well. But the reason it's important is different than academia. Academia, it's for the careers of the researchers in themselves. It's important for their lab as a whole. It helps you get more grants in because you're proven as a leader in your field. Then there's tenure issues at stake there. But for industry, you publish because it leads to more sales. And that's the thing, you can become a trusted partner, you become a trusted leader in that field because you're able to publish and show what you've been doing, and that leads to more sales. And again, industry is very much caring about the sales there, which then, of course, goes into information sharing. And the key differences there, because while academia is publishing, they generally want to share all the knowledge that they have. It's showing, obviously they want to be the first one to publish. They don't want to share the knowledge until they have published. But once it's there, it's a very much a culture of openness, which is, much appreciated. However, that does often conflict with industry, because industry wants to have a sellable product there. And to have a sellable product, you have to make sure that you protect your IP and that somebody else can't just go and do the thing you did. And, there's a couple of ways to protect your IP. One of them is by patents. And what that picture on the right is a company's patent filings in it was just a couple months worth where they just filed a whole bunch, and it was just all of that. It was in the QKD field. So I went and looked it up. You can try to do it by patent filing. You can also do it by keeping the information close to the vest and not disclosing it, because with a patent, once it's granted, you can see everything written in there. And so it's all out in the public, and then you're basically relying on the fact that you have a patent and you can sue in order to protect your IP. But the other way to do it is just to not tell anybody you have, what you've done, which obviously goes against the academia's wish to publish what you've done and show, the new novel things. And so that's something that really has to be discussed at the start of just, what it is you can share and what you should not be sharing. Because that makes sure that, everybody gains from the project, because it's the project isn't just the product at the end, but it's the process throughout and what both partners gain from it, including publishing rights. And so to make sure that everybody, again, has their own version of success realized for a project, knowing what you're going to be allowed to publish and what you're not is very important at the start. And that was everything. So I guess if there was any questions, I realized it was only 5 minutes.
Awesome. Well, thank you for the very great and insightful talk, Cassandra. That was really eye-opening. I was really not aware of some of those differences between academia and industry and sort of working together, how it can be and how ruthless maybe you have to be at points in the process. So we have a couple of questions for you from the Q&A. So I'll just kick off with one of those. So anonymous attendee says, thanks so much for the talk, Cassandra. It's been great listening to you. Is Agile the prevalent project management framework in the quantum industry, or are there other methods we should look into if we're interested in learning more?
That's an interesting one. So yeah, it's Agile is not a full project management on itself. It usually sits on top of something. So there's Prince 2 Agile. It's a kind of a way to think about things on top of project management, and it is for most of the startups. So they go with Agile. And even some of the larger companies are trying to put Agile thinking into it, because what it does really promote is this idea of development in shorter cycles, build, test, build, test, build, test, instead of just long periods of design. And so this allows you to really come up with new novel things, and the embracing change is a super important part for R&D. So I would say, yeah, Agile is very prevalent in basically, all startup industries.
Okay, yeah, that makes sense. I've heard about Agile before, and it sounds quite like this new kind of way of thinking, and adapting being the core kind of principle. Yes. Just you talked about the difference in approach between academia and industry. So academia is more thinking and pushing the frontier of knowledge. But thinking about if I'm doing a PhD, I've still got goals that I need to hit. I still need to adapt throughout. Do you think Agile could sort of form or maybe Agile inspired approach to doing PhD research? Because you can go down roads and lead to dead ends, which might be useful, but ultimately you need to be on track for your PhD at the end of the day.
Yeah, any sort of basically project management, it's a super great format to put on top of it, So if you have a defined, so a project, and really what Agile is good for is when you have a project and you are not like definitive and super sure of everything you need to do for it at the start. So Agile really has that adaptive framework built into it. So any sort of thing of when you are doing research, and you want to get to something that looks like this, but you're not sure how to get there or what exactly looks at the end, which is basically PhD work. It is a perfect thing to put on top.
That's exactly how I feel when I'm doing my PhD. Do you know of any good resources maybe you could put in the Slack channel for people to sort of check out for Agile, like Agile 101 or something?
Let me look. I think I have some, and I'll see if I can include that in. Yeah.
Awesome. We have a different question now, not related to Agile. How do you achieve a product market fit when you are building a quantum technology?
So, that's an interesting one. So what we've been doing is we've been developing this, these products basically for about 2 years now. One of the ones is we're doing our own mission. So it's the ROKS mission that we were talking about at the start. And so that's going to be a demonstration of QKD. And so some of the things that have come out of there, we're able to see oh, hey, this can actually be its own product. One of them is the quantum source module. And so that was working, basically networking. The quantum community isn't that large, and so we know what the other projects are going on, and there was an opportunity to basically do a joint development so that we can work with Canada. There's a couple of other ones where basically you allow the one grant, you get a product at the end. And that's part of having the industry partners is you have what you call commercialization roadmaps. So this is your company, not for just a particular product or project. And so you see where different items basically help lead to better and better products. And then you have targets that you can go and look to sell for those different ones. So the first, breadboard versions that we are having, that was for us, and that was part of an R&D grant. And we knew that we could make a product from it. And so then it was networking for another opportunity that we get version 2.0 that's going to get delivered. And then from that one, we're actually having now commercial interest for products that come for the versions of the quantum source module for afterwards. So that's also part of the publishing. Why it's also important for industry is to get your name out there of what you're doing. And it's working with partners. We've also been working with QRNG manufacturers so that they have a product market to go to. And so that's super important for them. A QRNG is a quantum random number generator. I'm sorry, I use a lot of acronyms. And so that's important for quantum key distribution. You have to have a random number base. And so when you're looking, it depends on what your product is. For us, a quantum source module, who has need for quantum source modules? Well, it's going to be universities doing quantum experiments. It's going to be countries that are doing quantum key distribution in space. For a QRNG manufacturer, it's going to be, well, who needs QRNGs? It's going to be people like us. It's some other people with needs for high security. And so part of it is you're developing it and you're already reaching out during the R&D phase to get those partners in that you're going to be having as customers. So it's very iterative.
Yeah, and looking ahead and looking at where links can be made, and you can sort of sustain and support each other throughout. Awesome. Well, thank you very much for answering these questions. We've sort of run out of time now, but I encourage everyone to put any questions they have for you in the Slack channel, and if you could have a look at them, that would be awesome. And yeah, any sort of maybe material you could sort of suggest to people to look into, that would be fantastic. But yeah, I'd like to thank you on behalf of everyone that's attended and the committee for giving this excellent talk. And yeah, thank you very much, Cassandra. Have a great day.
Yeah, you too.